Assalamualaikum warahmatullahi wabarakatuh. So today I will explain about how to implement the circuit using Powerworld simulation. So this is the question given. First thing first, we just open the Powerworld simulation, go to the edit mode and choose draw tools. And firstly, we need to create all the 7 buses. Just click at the network and choose bus. For the example, for the bus 1, we just follow the question, which is 13.8 kilovolt for the nominal voltage, and for the bus 1 we set it as slack bus, so just click at the system slack bus and just follow all the steps until 7 buses were created. And for the second thing, we create the generator. For the generator, we have 2 generators here. For the first generator, for the both generator, we set it MVA base equal to 100 and just choose the fault parameter to change the positive, negative and zero sequence impedance. That is how we do the generator part. And then we continue to the load part here. For the load part, we need to create each load in bus 2, 3, 4, 5 and 6. So for the load, we just need to put the constant power value here. We change only at this part here. And then done for the load part. And for the transformer part, also have here, we choose transformer at the network. And for the transformer, same, just follow the question given from 13, let's say for the transformer 1, it's a 13.8 kilovolt to 230 kilovolt, and that's it. We don't need to change anything else. And for the last one is for the transmission line. For the transmission line here, from the question given, we know that every line have different length of the line. So what we need to do, just put the resistor, inductance and shunt value here and change for the length unit to kilometer and put our length of the line. And this power simulation will calculate the Rx and B value for us. So we don't need to do anything and just change the value at the zero sequence here for the X value. And also for the R, that's it. So that's how we create this circuit. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nazhan Ilham and I will be showing you how does the circuit works. Basically, this is the circuit for case 1, and to run or simulate this circuit, we go to run mode and tools. We have a green indicator here, press it, and yeah, basically this is the circuit looks after we have simulated it. As you can see here, this is the first generator and the value is 90. The value of power consumption for the first transformer is 90% and the second transformer is 71%. And the rest is line power consumption. Alright, the main objective is we want to calculate or we want to find the output, the data output. To see the data, we go to case information, we go to Model Explorer. Alright, we want to see the output data for each component, which is we have the first one is buses. Let's look at buses. Okay, we have 7 buses. So this is the output data for buses. Bus 1, bus 2 until bus 7. We have PU volt, we have angle, we have load, megawatt, load, MVR, and the rest of it. So the next component is we have output data for line. So we have 5 line here, and we have the value of R, value of X, B, and the rest of it. So basically this is the output for line. And last but not least, we have value for the output data for transformer. Like I said before, we just have 2 transformer. So this is the value for the transformer. It's the same, we have R, X, and B, also the rest. Yeah, I think that's all from me. Thank you very much. On to the next person.
Next, we will move on for case 2. In this case, we were assigned to increase the voltage at bus 4 by 5%. The method that we use to increase the voltage at bus 4 is by installing a shunt capacitor bank at bus 4. To execute this, click on network and click on switch shunt, and then double click at bus 4, and this option will appear. Then we will have to change the value of this nominal MVAR. This value can be calculated, but to get the closest value to 5% of the original voltage, we use trial and error to determine the value, and we ended up with the value of 55.
Assalamualaikum. My name is Muhammad Hazwan Nabil Muhammad Nazri. So I will talk about for the case 2 and the output data. So as you can see here, for the case 2, we put the shunt capacitor at the bus 4 to increase the bus voltage by 5%. So for the case 1 before, the PU voltage at bus 4 is 0.91769, and the target we want after we make the calculation by 5% that we want is 0.69358. That's the value that we want. So we need to run it first, and then we go to the Model Explorer. At the bus 4, you can see that the PU voltage is 0.69323. So after we decrease the capacitor shunt manually, so this is the nearest value that we get. And for your information, the shunt capacitor bank function is for increase the voltage by supplying reactive power locally, which means it reduces the reactive power demand from the upstream network. So that's it for me. Thank you.